Hello, everyone. Thank you for joining us here today on Feedstuffs 365. I'm Sarah Muirhead. Today, we're going to dig into some new research coming out of the University of Minnesota that's showing how diet composition and U.S. geographic region can potentially influence greenhouse gas emissions, water consumption, and even land use when it comes to pork production. Joining us to talk about the recent findings are Dr. Gerald Shurson, professor at the University of Minnesota's Department of Animal Science, and Dr. Rylie Pelton, research scientist at the in industrial ecology at the University of Minnesota Institute for the Environment. Welcome to you both. Thank you so much for joining us here today.
Thanks, Sarah.
Yeah, thanks, Sarah.
So, Dr. Shurson, we've been reading and hearing a lot about sustainability from all the commodity groups, especially pork and soybean. How do these results from your study that you're working on, how do these fit into these stories?
Well, I think it's a great question, and I think there are several different approaches that we used in our study that add to the narrative. And by the way, it's great to see so much interest and engagement and discussion around what I think Rylie and I would consider the most important topic in facing agriculture globally and certainly here in the U.S. But I think what separates the results of our study from previous studies is, first of all, we really focused on what I call the consumption pathway as compared to the production pathway, which most of the narrative and stories have been about up to this point. And what I mean by the production versus consumption pathway is that in the production pathway, a lot of the emphasis has been on the positive environmental impacts of increasing productivity, whether it's improving feed efficiency in pork production, improving pigs marketed per sow per year, and other productivity measures. In other words, doing more with less, but not as much has been focused on the consumption part of this story, which really involves the inputs, the feed ingredients, and the feeding programs that go into pork production. And in fact, a lot of the previous work that's been done in this area would indicate that about 50% of greenhouse gas emissions associated with pork production are really attributed to feed and feed ingredients. So that's one of the, I think, new pieces of information that's provided in the published paper that we're providing everyone to access here today. And I would say the second one is really coming down into the details of how crop production in different states, different counties, different geographic regions across the United States impacts environmental footprints of corn, soybeans, which eventually becomes soybean meal, and even DDGS for that matter. You know, we've known for a long time that management practices vary, whether it's no-till or conventional or cover crop, soil types, climate, yield differences across different geographic regions, and even fuel grid mixes make a difference. And so our work really captures a lot of those county level geographic differences attributed to some of the main feed ingredients that we're using in U.S. pig diets. And this is really what I think separates our work from all the other life cycle assessment, environmental impact work on feed ingredients that's been done up to this point. So in other words, we provide some new LCA data, life cycle assessment data, for U.S. feed ingredients, which I think are really, really needed at this point. Probably a third difference is that we also have to recognize that manure is second most important and is related to feed, second most important to feed itself as a contributor to greenhouse gas emissions and environmental impacts. And there are pretty substantial regional differences in how manure is collected, stored, and managed on swine operations across the country, ranging from anaerobic deep pits here in the Midwest to open lagoons that have increased emissions of gases, let's say in the mid-Atlantic state region where pigs are produced. And certainly we have a lot of farms that are using anaerobic digesters to convert some of these raw materials into valuable biogases that can be contributing toward the energy grid as well. So accounting for those differences, I think, is another major contribution that our work is providing beyond what's been done before. And then maybe the last one is we also wanted to take a look at challenging our readers and people to think about alternative feeding programs. What can we do differently than simply relying on our traditional corn and soybean meal diets? Can we actually make the big lift and go toward using some heat processed, thermally processed, dried supermarket food waste, for example, in swine diets to reduce environmental impact? Can we reduce the protein content substantially and use more synthetic amino acids? What impacts will that have? And so it really led us to asking some key questions about, first of all, how does geographic region, and secondly, feeding program affect greenhouse gas emissions, water use, and land use in pork production systems?
So can you show us some examples? I think you have some slides. Can you talk to us about the geographic region of corn and soybean production and how that has environmental impacts on pork production?
Yeah, let's take a look, and maybe starting off with this slide, I should mention that we actually formulated five different feeding program types of diets. The first one was a corn soybean meal based standard diet, no other additives and so on, minimal synthetic amino acid use. And then we also put phytase enzyme in there, which of course is commonly used and a really valuable additive to reduce our phosphorus footprint. But beyond those two base diets, we also use corn soy diets containing 15% DDGS, which many people are using in their grow finish feeding programs today, along with 8.5% or 8.6% food waste as another alternative, and then the low protein, high amino acid supplemented diet. So those are going to be the comparisons we're going to be making as we go forward today. But I wanted to start off by saying that it may be a little difficult for the audience to see, but you'll notice some green lines flowing from one direction to another, and then you see some of these pink or other lines representing flows of pigs to primary pork processing facilities. This is the mapping of the flows of corn from production to consumption by pigs, which is unique with the Foods Cube model that our team is using to produce these life cycle assessment results. And it also accounts for the flows of pigs going from production systems into primary processing regions. So because of these geographic differences, our Foods Cube model allows us to aggregate these effects, particularly for feed ingredients and their environmental impacts, and helps us really identify hotspots or areas for opportunities for improvement on reducing environmental footprints, but also for individual operations, pork operations, to think about sourcing ingredients from different regions to minimize their environmental footprint in some of their feeding programs. So this is a really important component of our Foods Cube model that we use to establish our LCA data, life cycle assessment data, moving forward. We also focused on basically three of the major pig production regions in the U.S. Of course, everybody recognizes the Midwest, shown here in yellow, which represents about 76% of our total market hogs produced annually. Secondly would be what we're calling the Mid-Atlantic states, shown here in blue, North Carolina, Pennsylvania, Virginia, et cetera, representing about 15%. of total pigs marketed. And then the red states shown here are the in the Southwest represent about the remaining 6%. So we're accounting for almost all of the major pork production areas in the U.S. And you'll be seeing these color displays representing these three different regions as we go forward in talking about some of the data that we've generated. The next part of the story is accounting for these regional differences. And again, yellow is Midwest region, blue is Mid-Atlantic, and red would be the Southwestern states. Here we're talking about greenhouse gas emissions that are attributed to ingredients used in feeding programs for pig production in these different regions across these four different major ingredients that we included in our diets. Here's corn, for example, soybean meal, DDGS, and food waste. And you'll notice that, sorry, skipped ahead here, that soybean meal had the highest amount of greenhouse gas emissions as a carbon dioxide equivalent per kilogram or per pound compared to corn, which was quite a bit less. DDGS was comparable to soybean meal, with food waste having the lowest greenhouse gas emissions. And again, these are life cycle assessment carbon dioxide equivalent values that we assign to these different ingredients that we then included in these different diets that we formulated to represent these different four-phase grower-finisher feeding programs that we wanted to compare. And notice that the other big difference is that the Midwestern region had the lowest greenhouse gas impacts of all ingredients, certainly compared to the Mid-Atlantic or the Southwest regions for this particular measure. For water consumption, there wasn't a huge difference among different types of ingredients, whether it was corn or soybean meal or DDGS, but the biggest difference was the dramatic contribution of water toward crop production in the Southwest region. And that's probably not a big surprise because, we've been going through quite a bit of drought, particularly last year and even prior years. And that part of the United States is pretty deprived of rainfall. And so irrigation is a big part of what goes into crop production. And therefore, the Southwest region clearly has a much higher water consumption footprint for these ingredients than our other geographic regions. If we go on to land use, which was the third major environmental impact category that we wanted to evaluate in this study, notice again that corn had the least land use impact. Food waste actually had the least because we're actually recycling nutrients from food that was intended for human consumption into animal feed in this case. And so there really isn't a land use charge, so to speak, like we would have for our crop production. But so food waste actually had the least, followed by corn, then DDGS, and then soybean meal. And again, the Midwest region of all regions had the lowest impacts for all of these different ingredients. So when we take those ingredients and then we formulate nutritionally adequate diets in a four-phase grower-finisher feeding program, which is what we did in this study, and then we assess what those impacts are in these three different geographic regions, notice that the contribution of feed toward greenhouse gas emissions was the lowest in the Midwest region. And I'm showing ranges and numbers here. These are from the lowest to the highest feeding program values that we got in this comparison. I'll talk more about that later. For purposes of this comparison in the Midwest region, food waste at 8.6% of the diet would give us the least amount of greenhouse gas emissions. Actually, the DDGS diets give us the highest greenhouse gas emissions within this region. And sometimes feeding programs varied from one region to another, but that's what this range represents, are kind of the minimums and maximums of what we found from the different feeding programs. The main point of this story is that the Midwest region had much less greenhouse gas emissions compared to the Southwest and the Mid-Atlantic regions in terms of pig production, using the same types of diets, the same types of feeding programs. So geographic region makes a pretty big difference. If we account for the manure contributions, now feed, of course, goes into the pigs, they grow, and then what comes out is manure, and that has environmental impacts as well. And so what we're showing here are the calculated values for greenhouse gas emissions attributed to feeding program based on these three different geographic regions. And notice that the Mid-Atlantic region had the highest greenhouse gas emissions attributed to manure from these feeding programs. Southwest was second, and the Midwest had the lowest. And again, a lot of this has to do with differences in manure management, storage, and handling procedures across these different regions. So when we combine the greenhouse gas emissions attributed to feed plus those that are attributed to manure that I showed in the last slide, it's no big surprise that the aggregated effect, still the Midwest has a decided advantage in lowest greenhouse gas emissions footprint per market hog produced compared to these other two geographic regions, with the Mid-Atlantic region actually having the highest greenhouse gas emissions. If we move to water consumption attributed to feed or feed ingredients per market hog, again, as I showed with the differences in the feed ingredients earlier, the Southwest had the greatest water consumption impact by far in pig production, with the Mid-Atlantic having the least, and the Midwest having a fairly low, substantially less than Southwest, but somewhat greater than the Mid-Atlantic water footprint relative to production of market hogs. And then for land use, again, because of yield differences, climatic differences, soil types, and crop management practices, producing ingredients that are used in these diets across regions, and the flows I talked about earlier, the Midwest had the least land use per market hog. Again, seeing some ranges here based on differences in feeding programs. We'll talk about that here in a moment. The Southwest and the Mid-Atlantic were pretty comparable in terms of land use impacts per market hog. So just to kind of wrap up our diet comparisons, our feeding program comparisons, here I'm showing the effect of feeding program on greenhouse gas emissions, and I'm combining the feed and manure impacts together, indicating that of all these four major feeding programs that we compared, and you can see the regional effects based on the different color schemes as well, that the food waste feeding program gave us the least greenhouse gas environmental footprint, followed by the low crude protein amino acid supplemented feeding program. And the DDGS feeding program gave us the highest greenhouse gas emissions. And, some of these varied a little bit from one region to another, but feeding program, like geographic region, does make a difference. For water consumption, there weren't huge differences across different feeding programs. Certainly the food waste program gave a slight advantage compared to the other feeding programs. And again, the glaring disadvantage of the water footprint in the Southwest region really shows through when we track water footprints relative to feed used in pork production systems in that region. And then, of course, the impact on land use attributed to feed relative to feeding program. Here we see some, again, another advantage of using the food waste feeding program compared to some of the others. giving us the least land use footprint, followed by the DDGS feeding program. And the low crude protein amino acid program were fairly similar compared to the corn soybean meal program. So depending on the metric that we want to use, greenhouse gas emissions, water use, land use, we do get different answers depending on what feeding program we want to compare. And again, we get different answers depending on what region of the country of pork production we want to compare. And so having this kind of new matrix really helps us understand where some of these hot spots, where some of these opportunities are for improvement, and hopefully allows us to make some major improvements on this consumption pathway to go along with the great stories we have to tell on the improvements in productivity that have been achieved in U.S. pork production.
So, Jerry, basically what you're telling us is that where pork producers get their corn and soybean meal can make a difference in the environmental impacts of pork production, what that will be. Given that, how does a feed formulator use this knowledge to formulate environmentally friendly feed for actual pig farms?
Well, I think that's the really cool opportunity that any of us that work in the feed industry or in nutritional circles really have right now, of adding another set of constraints on top of our, least cost or best cost feed formulation. We're trying to minimize cost, meet all the requirements, manage our feed additives to give us those important responses that we're looking for in terms of pig performance and carcass composition. But adding another set of variables, such as the life cycle assessment impacts, having accurate data, allows us to use what I call multi-objective feed formulation. We've been doing that multi-objective for a long time, but adding another objective, and this would be greenhouse gas emissions, LCA impacts, land use impacts, could be eutrophication potential, acidification potential. Many of these indicators are part of a large feed ingredient database known as the GFLI database, based in Europe, but now being expanded to include more U.S. ingredients. That's been a real disadvantage up to this point of using that database, because it hasn't captured these kinds of differences that I'm talking about today relative to U.S. corn, soybean meal production, and so on. But now we're generating some of these numbers, and so we can start using accurate U.S.-based data to start making some of these important decisions and formulating eco-nutrition feeding programs.
So you mentioned multi-objective feed formulation. Are there any drawbacks, in your opinion, to that approach?
Yeah, I would say there are a couple right now. One is, as I briefly mentioned just a second ago, having accurate data is really key. It's got to really represent, like our data does, county level, which nobody else has, even in the GFLI database. Most of that is national, some of it's state-based, but you really need to, if we're going to get serious about this, and we certainly have to, having county level and accurate LCA data for feed ingredients is really critical. And so we think that this is an important step toward achieving that goal. And I would also say that the other big thing that we assumed in all of our work in this study was that growth performance and carcass composition and manure composition and emissions were the same or unaffected, let's say, by feeding program. And we know in reality that's not necessarily true. So one of the drawbacks is that we have to account for growth performance differences, carcass composition differences, and manure composition differences in the feeding programs that we're evaluating using life cycle assessment data in particular.
We do have a question from the audience that I want to get to here. What allocation type did you use on the ingredients in your simulations? Was it economical, physical, or other?
Rylie, why don't you do that one?
Yeah, I can jump in on that one. So we used actually energy allocation, which is a physical allocation approach. And the reason why we did that is, one, because it aligns with the biofuels industry in that, for soybean meal and for DDGS production, the co-products or the primary products of those processes are oils, in the sense of soybean oil, as well as ethanol, alcohol, and both of those are energy related products. They're used for caloric and bioenergy, and the co-products of those processes are also related to energy use in the sense of feed needing to have an energy content and value. And so the energy allocation approach is not affected by a lot of the fluxes of an economic approach, where in some cases ethanol fuels might be the primary value added product. Certainly there would be more impact under that scenario allocated to the ethanol than the DDGS, whereas under an energy allocation scenario, more of the impacts are distributed between those co-product outputs, because they're both used for an energy function ultimately. So
very good. I want to thank our audience for that question and encourage you guys all to post additional questions if you might have those. Jerry, want to circle back around. You mentioned life cycle assessment, which is a term that we've all been hearing more and more about in all these environmental sustainability discussions. Can you explain this term and how it applies to feed ingredients, swine diets, and pork production?
Well, I think that's a great question for Rylie again. So I'm going to turn it over to her and let her explain in more detail.
Yeah, sure thing, Jerry. So LCA, life cycle assessment, in general, is an accounting method that tracks the inputs and the outputs of a production system and the associated environmental impacts of those inputs and outputs throughout the entire value chain and life cycle of a product. And so this includes the extraction of the resources, processing those resources, transporting, ultimately using and disposing of those resources, which collectively is known as a cradle to grave LCA. And many LCAs are, there are different system boundaries that stop at the processing gate. It doesn't often cover the use and disposal stages. And so you might hear that term as a cradle to gate life cycle assessment. And so LCAs in general, and Jerry, you mentioned this, that, most account for impacts for greenhouse gas emissions, water consumption, and land use. And that's what our study focused on. But there are multiple other impact categories that can be accounted for, like eutrophication and acidification and others. And so, in the context of feed ingredients, a cradle to gate life cycle assessment would include the emissions associated with the manufacture of inputs used on fields, like fertilizers and fuels and other inputs, as well as other emissions associated with the application of the fertilizer to the fields and combusting the fuel in farm equipment, and then the subsequent processing required to ultimately make the final feed product. So in the case of soybean meal and DDGS, it would also include the emissions from the soybean crushing and ethanol processing that partially get attributed to those co-products. And Jerry had mentioned that some of the impacts of feed production do vary substantially across the U.S., and largely because of these differences in management practices used on fields and their interaction with the environmental conditions, as well as differences in regional fuel mixes and others and yields. And so, as you might expect, there are certainly differences across the landscape within a given feed ingredient type, but also substantial differences across different feed ingredients due to the differences in yields and inputs used and various ways of processing. And so when we take that and think about the cradle to gate LCA of a swine diet, what that would include is all of the emissions from the feed ingredients themselves in the upstream production of those feed ingredients, and ideally would include some sort of ability to incorporate the spatial differences in production and how transportation and sourcing information ultimately get attributed to these different impact profiles and how those production impacts, ultimately aggregate differently in downstream supply chains. So swine diets obviously are the feed component, as well as the consumption of those feed diets and the metabolization of the feed, which affects the amount of volatile solids generated, the amount of nitrogen that gets excreted, and ultimately the methane that gets generated from the pigs. And so a swine diet LCA would ideally include both upstream as well as the impacts of feeding the feed to the hogs and the manure outputs and emissions associated with those manure outputs. And then you'd mentioned, Sarah, that on the processing side of things, a cradle to gate LCA of pork production would include both of those first two stages of the value chain, feed ingredients as well as the manure, but also the other inputs used on farms and the transportation of the hogs to the final processing facilities, and then the energy and other material inputs that get used within processing. So overall, the LCA of the hog value chain for producing pork, by looking at these individual stages, we can ultimately understand the spatial differences and the hotspots that exist within the supply chain. And these hotspots allow us to identify where there are potential opportunities and levers for mitigating the impacts across the different stages of the product life cycle.
Your team's been doing a lot of work in this area over the last several years, and you've looked at different commodities and such. So we have included some of the links to those publications, to those to that work down below. If you folks want to scroll down and check those out at any point, they will also be part of the archived edition, so you can go back and look at those. Now, since you've been involved in most of these studies, what advice, Rylie, would you give to our audience, which livestock producers, crop farmers, feed industry folks, animal nutritionists? What advice when it comes to the high impact things that they can do to reduce the environmental footprint in U.S. agriculture? Can you give us kind of that overall view of what you're thinking might be on that?
Sure. Yeah. So I guess a couple things come to mind, and it'll depend on who you are within that value chain. So, for example, for hog and dairy producers, which have a pretty widespread widespread number of different manure management systems that are available and are used in the U.S., if we can increase the deployment of anaerobic digester systems, which capture the methane, the biogas, and use that as an energy resource, that's a major opportunity because one, it's an economic opportunity for farmers to have some diversification in revenue generation, in that the biogas could be upgraded to renewable natural gas for injection into pipelines. It could also be directly burned in turbines and generate electricity for either use on site or to be sold to the grid. And both of those offset the growing demands for grid fossil fuels and fossil fuels in general. And so, it would ultimately lead to opportunities to mitigate emissions from both agriculture, because we're no longer emitting the high global warming potential methane. And it also mitigates some of the emissions from the electricity and stationary combustion sectors as well. And even if the methane isn't captured for use as energy, and if it's just flared, burned, it also mitigates a substantial amount of emissions because of it being a biogenic CO2. And so various things that could enhance the adoption of anaerobic digester systems could be, partnership programs and financing options like green bonds and other preferred purchasing mechanisms that help ultimately to create the incentives and remove the cost barriers for accelerating the transition to these more expensive but hugely mitigating manure management systems. So that's a key area. I'm sure that doesn't come to a surprise to many of the audience here. But in terms of feed producers, intermediate processors like soybean crushers and ethanol producers can also reduce impacts for the feed that they're producing for soy meal and DGGS. A lot of the impacts of soy meal, for example, about half of them are attributed to the soy meal production stage, again, using that energy allocation procedure. And so adoption of renewable energies in processing for both electricity as well as renewable natural gases for drying DGGS and meal cakes could be a big win as well. On the field, there's a lot of different options that could be taken. Land use change, as Jerry mentioned, is a big component of the impacts of both corn and soybeans produced in the U.S., which is not often considered because you often think land use change from Brazil and other heavily forested locations. But in the U.S., land use change is significant particularly as it relates to grasslands. Much of the grasslands or much of the land use change has occurred from converting grasslands to corn and soybean production systems. And so by limiting that expansion and by intensifying, crop production on existing croplands, that can help reduce emissions moving forward. And there's also, various crop management practices like 4Rs, which stands for the right timing, right placement, right amount, and right type of fertilizer being used on fields, and adoption in general of precision ag, farming technologies helps to more efficiently utilize those resources and optimize yields. And then, as we saw, irrigation can be a major source of both water consumption and emissions in parts of the U.S. that are heavily irrigated. And so by transitioning to either higher efficiency irrigation powered systems, such as electricity powered systems, or entirely moving towards a gravity fed operation, these can also reduce greenhouse gas emissions, although there might be some trade-offs in other areas like water consumption. So those ones I think are well documented and found. Tillage certainly is an area that is something that can increase the carbon sequestration potential of soils. However, there are some trickiness in terms of where to deploy that because of interaction with N2O and other things. So I guess the last thing I'll mention here is just the grazing side of agriculture, where grasslands are being used for producing cattle largely and other livestock, and these grassland operations keep a lot of the carbon in the ground. We don't want to plow those under for more crop fields necessarily, but there's also opportunities to increase the carbon sequestration potential of that grassland through, let's say, silviculture or silvopasture, opportunities that have been found to show significant carbon sequestration by just introducing some trees to the landscape, which also has some potential co-benefits to cattle producers, which might offer some additional shade opportunities that can help reduce heat stress and overall resilience of cattle herds in the face of these changing climates. So I think overall, there's as our study has shown, there's opportunities too to change out feed diets for alternative feed diets, such as incorporating more food waste. But there are a lot of dynamics that need to be considered to understand that net effect, which our paper did attempt to show, in that there's the upstream changes as well as the downstream changes on manure emissions that need to be considered. And unfortunately, some feed optimization softwares are beginning to incorporate those dynamics, and so we'll be able to have a better picture of how what the net implications are of changing out food diets. But in general, as Jerry has shown previously, that the place of consumption matters in that equation, and so that's an additional area of evolution, I think, that feed optimization softwares can pursue to better understand those differences in impacts, as well as the leverage points for how to reduce those impacts.
Definitely a lot to consider. We do have some questions that have come in. First question, and whichever one of you wants to jump on that, or you both can here, but does the quality of water in swine barns contribute to the amount of feed consumed? For example, treated water with correct pH level versus normal well sulfur water that has bacteria and biofilms in water lines. Does that make a difference?
I can try to answer this. Thank you for the question, Brock. I don't think we know as much about water quality as maybe some of us think we do. Our team here at the University of Minnesota in animal science, and I've been involved in some work many years ago when I was at Ohio State University evaluating water quality effects, especially sulfate effects. I think it really depends on what you define as good quality versus maybe poor quality or unacceptable quality water. I think it's difficult to find water quality oftentimes in rural communities, groundwater supplies, and so on. That's bad enough to really have negative impacts on feed intake. Certainly the water consumption data that we're talking about here in our study is the water that's embedded in the production of corn and soybeans. So it's somewhat different than, the actual liquid water that pigs would drink on a pig farm. But it's a great question. And I'm not sure that we know that much about water and water quality, water consumption impacts on LCAs of pig production. But certainly that's a question that we ought to consider moving forward.
Jerry, another question for you. When formulating for environmental impact, do you anticipate cost of production to be affected?
It's everyone's favorite question. Certainly, we're at a stage in how we manage feeding programs and in pork production and how we design those programs. We always have to be cost conscious, value conscious, maybe is a better term, to make sure that we're getting the most productivity and health out of whatever it's going to cost us to feed those pigs. I answer that question a couple different ways. One of my favorite studies was conducted over at Rennes, France, with INRA, a research group that I spent some time with actually back in early 2020. And they, Francine DeKellen published a nice study that showed that when they formulated what they called eco-nutrition diets and fed those in a precision feeding program, this is individual feeding stations, adjusting diet composition based on constantly changing requirements, using the best technology that we have available. There really weren't any increases in costs. In fact, you could even argue that there were actually some benefits in terms of cost of production, while at the same time achieving some huge environmental impact or footprint reductions. Maybe a simple way to answer the question is most of the U.S. swine diets contain phytase nowadays. If they don't, they need to. Phytase is an environmentally friendly approach to reducing our phosphorus footprint. It's economical. It replaces some of our inorganic phosphate. So here's a measure that we can easily implement that doesn't increase the cost of production at all. In fact, it may keep it the same or actually decrease it. Using synthetic amino acids in reduced protein diets is another strategy that most nutritionists are using today that has some environmental benefits. So I think, we have to be careful and keep all this in perspective. And I think there's a lot of opportunities to formulate diets that are more environmentally friendly without increasing cost. And part of that strategy, I think, comes down, Rylie, to understanding our sources of ingredients and what those impacts are, where they're being produced. And you can make decisions based on sourcing corn from this location versus that location, and have an impact on your environmental footprint.
Another question here. Do ultimate end users, retailers, and consumers additionally account for these factors, such as including fuel cost associated with the shipping of animals? And is the environmental cost of fuel considered in these LCAs?
Rylie, do you want to take that one?
Yes, I certainly can. Yes, absolutely. So the idea of an LCA is to account for all of the potential sources of emissions, including fuel. And so, I had mentioned a couple of cradle to gate LCAs. If we just continue the system boundary, so to speak, down to the ultimate end users, the retailers, the consumers, et cetera, we would account for all those upstream impacts, as well as the transportation to the retailer, the transportation to the consumer, the cooking of the end product, ultimately pork, for example, and then its disposal. So yes, certainly we would want to account for all of those upstream impacts if we're looking at a retailer or a consumer.
So we're going to start wrapping up here today. So any last minute questions, be sure to get those posted now. Jerry, a last question for you. You have been an advocate for encouraging the use of heat treated food waste in animal feeds to reduce the environmental footprint. And you presented some of that information here today in terms of the sustainability of that. So give us, what does all that mean when food waste is added to the diet? Is it having an impact? How are we kind of sorting through that?
Well, you're right, Sarah, and it is an area that I've been very interested in, very passionate about, and we've published some studies, and I'm happy to share those with anyone that's interested, where we evaluated the metabolizable energy value and the digestible amino acid content and digestible phosphorus content of supermarket food waste, for example, which is kind of a blend of deli and fruits and vegetables and dairy and bakery, products coming out of supermarkets. And when you compare the energy and digestible amino acid and digestible phosphorus content of that mix, assuming that it's properly heat treated to destroy any sort of pathogens that we would be concerned about, it's got equal, if not better, energy value and digestible amino acid and phosphorus content than corn and soybeans or soybean meal. So when you consider that, along with the fact that here in the US, we're wasting about 40% of the food that's produced doesn't get consumed, to me, that's the low-hanging fruit that could revolutionize not only the cost of production of pigs, but also dramatically reduce the environmental footprint just by putting in a little bit, less than 10% of a diet of some of these really nutrient and energy-rich ingredients. The biggest problem that we've got is we don't really have an infrastructure set up within the feed industry or the food industry to segregate or manage different flows that may or may not be appropriate to go into animal feeds, especially swine feeds. We have a lot of concerns, perceived concerns, and fears, actually, about the risk of introducing foreign animal diseases into swine operations. And I understand that concern, because another big part of my world that I work in is helping everyone in the pork and feed industry to understand the risks of virus transmission through feed ingredients, especially African swine fever virus. So I think what's happened, though, is that people have associated food waste with some of these foreign animal diseases, because in countries where these outbreaks are occurring, they're not properly heat treating the swill or the liquid food waste that they're feeding to backyard pigs. And as a result, viruses are being transmitted. But here in the US, we don't do that stuff much, if at all, anymore. So I think understanding the context and evaluating the risk, I think, is something that really needs to be revisited. We also have a wide variety of different state by state regulations of whether or not, or if, different types of food waste are allowed to be fed within a given state to different species of animals. And that creates a lot of confusion for people that want to go regional or national with any sort of food waste recycling or upcycling into animal feed ingredients. And so I think those need to be revisited as well. And a lot of these kinds of challenges, I was fortunate to be invited to co-author a publication or an essay with Dr. Dow at the University of Pennsylvania as part of the Climate 21 Biden administration climate change discussions. And Sarah, I think you included that URL or that link to that publication, which kind of outlines what some of the challenges are. I think there's a real opportunity here. I think we have to be smart about it. I think we have to identify domestic sources of food waste that are appropriate to go into pig feeds. And if we do so and build the infrastructure and create the economic and government incentives necessary to do this, we could solve a lot of problems very quickly and make a pretty big difference.
So, Jerry, we do have just a comment from the audience. I don't know if you want to comment after I give you the comment, but just as a reminder, when phytase was initially introduced, it was not cost effective. Additionally, excessive use of synthetic amino acids, especially in health challenged flows, have increased costs. I don't know if you want to comment on that or just let that sit.
Absolutely. No.
Okay, go ahead.
No, that's a fair comment. But with any of these changes, and for all of us, change is difficult and painful oftentimes, right? But I think we're at a point in time in this is just Jerry Shurson philosophizing for a little bit, but I think we're all a bit uncomfortable with having to start thinking about doing things differently to make a difference. And there's no doubt that anytime you introduce a new technology, whether it's phytase, or start learning about increasing the use of various types of synthetic amino acids, mistakes get made, disappointments occur. They may not be cost effective initially, but over time, with refinements and new innovations and adoption and modifications, we can figure out how to make these things work. So I really appreciate the comment. And a lot of this stuff, it's not easy, but I think if we're smart about it and we spend some time discussing and talking through some of the challenges, I think most of these things are pretty solvable and will really enable us to achieve the goals that we're all interested in achieving.
So where are we at in terms of this research that we've been talking about here today? Is it published? Is it in the process of being published? Or we have a audience wants to know.
Yeah, the study that we're talking about today is accepted for publication in the Journal of Animal Science. There's a link, Sarah, I think you've provided everyone. It's in the final stages of production right now. So the PDF or the final pretty version will be coming out, I think, here shortly. But yeah, it's accepted and for publication in the Journal of Animal Science.
Very good. And we do have another question. Do we need to revise impact factors on DDGSs and soybean meal based on biofuel policy changes? Is the goal of agriculture producing food versus fuels? Impact factors may need economic attribution.
What do you think, Rylie?
Yeah, I mean, this is a sort of age-old debate around how to allocate impacts. Ultimately, a sensitivity around economic versus energy allocation is probably warranted. It doesn't necessarily mean changing the impact factors per se. It's just different ways of allocating impact. And different schools of thought are around that. As one audience member had mentioned, this physical approach versus the economic approach. I tend to be in, I guess it depends on the product category, but there's guidelines, ISO guidelines around which allocation approach to use. And it's related to the function of the products that are being produced. And so that's why ultimately we chose energy, because both products, both ethanol and DGGS, are ultimately fuel-based products. One's used for caloric fuel and the other is used for energy or biofuel. And similarly with soybean oils. So that relationship, the energy content of those outputs are pretty consistent over time in different processing pathways. And so to maintain some of that consistency, that's ultimately why we chose the energy allocation approach. There certainly are arguments for why we might have chosen the economic approach. And so ultimately it's ideally including both to see sort of how impacts might change and how regional impacts might change as a result.
Very good. We've had a great discussion here today. We're gonna wrap up. We're coming up on the top of the hour. Our thanks to Dr. Gerald Shurson and Dr. Rylie Pelton for joining us here today. A reminder that there are those references posted below if you would like to check those out. Likewise, all Feedstuffs 365 programming is available in archive format on Feedstuffs 365. So if you want to go back and watch any of this or watch the whole thing again or any of our other programming, you can do that at any point. For all of you innovators and out-of-the-box thinkers when it comes to soy, you'll want to join us tomorrow when we talk with the Yield Institute about the Soy Innovation Challenge and how you can be part of that. Until next time, for Feedstuffs 365, I'm Sarah Muirhead.